Hello everybody, welcome to my channel. Today we have a very good problem for you guys called merge intervals. So this is a very good problem, so make sure to pay close attention to the problem statement, right? So it says given an array of intervals where intervals of I as the start and an end, right? Merge all the overlapping intervals and return an array of the non-overlapping intervals that cover all of the intervals in the input, right? This is a very concise and good problem statement, right? So pretty short. So you can see the list of intervals that we have, right? Right? And our job, right, is to return a list of intervals, right? But the thing is, right, there will be no overlapping intervals, right? So the intervals that we return, right, they need to be non-overlapping, right? So to be able to achieve that, right, it means that we have to do some sort of for the intervals that do overlap, right, in the original input, we need to find a way to merge them into one, right? And then so that make sure that all the intervals that are returned are non-overlapping, right? So if they overlap, we go ahead and merge them pretty much, right? And then after merging, make sure that it doesn't overlap with other ones as well, right? So that make sure it's not overlapping. Okay. Looks good to me. So we have 1, 3, 2, 6, right? So we see that this is the output, right? So how to get that, right? We have 1, 3 and 2, 6 that overlap, right? Which becomes 1 and 6, right? So we make it as big as we can, right? Pretty much, right? And then it says merge them into 1, 6, right? And then after that, nothing else overlaps, right? 1, 6, take care of 8, 10 doesn't overlap with this one. 15, 18 doesn't overlap with anyone, right? So we return them as is, right? So pretty simple. So this one, you see that we have 1, 4, 4, 5, right? So I like that they really brought this particular example, right? Because it's gonna help us handle this particular edge case, right? So they're saying that if it if it starts where exactly where this ends, right? Right. So start and end, like if two intervals, right, they start and end, right, the other ends at the same time, right? It means that it's overlap, right? So we go ahead and merge them together into the bigger interval, pretty much, right? So how can we solve this, right? That's kind of what we're gonna need to come up with. So what we're gonna do, like we normally do, we're gonna bring you guys to the drawing board and kind of come up with ideas, and hopefully we can able to come up with like solution, pretty much, right? So let's quickly go ahead and go through them real quick. So she's just the first question, right? We have a list of intervals 1, 3, 2, 6, 8, 10, 15, 18, right? So just went ahead and drew them out so you guys can visualize it better and hopefully come up with the algorithm a little bit better, right? So this is not drawn scale, so don't like try to measure. That's not the whole gist of this problem here, right? Our job is to merge the intervals that do overlap, right? So looking at this, right, we could visually easily see this right off the bat, right? We see that 1, 3, and 2, 6, they obviously overlap, right? The overlap thing is right there, right? Okay, okay. So just making it visual for you guys, so you guys can see it, right? So this is the overlap portion, okay? So we could visually see it easily, right? And we can see that they overlap, and because they overlap, we go ahead and merge them into this a bigger interval, right? So from 1, which is around there, and 2, 6, right? So how we do the merging, right? The merging happens, right, when we, so we choose the biggest out of the two, right? The biggest end time, right? Pretty much because we're trying to extend it as much as we can, right? So that's why we end up choosing the biggest one, right? Like that, right? And then yeah, in the 8, 10, this is our return, just like how we have it in the original one, right? We return it like that, right? But how can we have an algorithm, right, that works in all the different cases, right? This is a pretty easy case. Nothing really done, right? Things are conveniently sorted already for us, right? And things are just lining up perfectly. But in some cases, guys, right, things may not be sorted. So we're gonna have to do some sort of sorting, right? Because in this question, they didn't really say that the things are sorted, right? And I believe that they're not sorted, and we have to sort them, right? So in those cases, right, we don't get it sorted. We're gonna have to, like, make sure we sort them every time, right? So that whatever algorithm that we end up doing, right? Okay. So right, because when it's not sorted, right, and we don't sort, right, so 1, 3, right? For each interval, right, we would need to go ahead and find the for in the rest of the array, right, for intervals that may potentially overlap with it, right? So we see that we would be doing a lot of repeated work because finding intervals that overlaps with us, right, would be a challenge because we would need to search the whole array pretty much, right, trying to find potential one, right? But if we end up doing the sorting right off the bat, right, you can see that we could easily check with our neighbors, do we overlap or not, right, as we go through the array in a linear fashion, right? So that's kind of what this helps, right? So we sort it by their start time so that we take care of the uh, we take care uh, of the intervals as they start, right? And then we check in future iterations, right? If the future iteration, right, do any of those intervals, right? Because we sorted them by the start time, right? So the second interval that started, does it overlap with the previous one, right? If it doesn't, then we would do something, right? So the algorithm of choice, right? How we're gonna end up doing it, right? The whole process is gonna be done this way, guys, right? So we sorted by the start time, right? So after we do the sorting, we're good. Things are right aligned. We could easily check our neighbors, right, for potential overlap scenarios, okay? So what we're gonna have to do, right, I'm thinking we can use some sort of a data structure that can help us to add intervals as we go, right? So this interval, this data structure is gonna be this, right? We go ahead and add the particular interval that we're on, right? So we start off. So if it's empty, right, we go ahead and add the interval as is, right? Okay, the first interval by the start time. Okay. After we end up adding it, guys, right? Okay, we would just go on to the next iteration, right? And now the next question that we're gonna ask, right? So we would initially it will be empty, right? And then we would add a 1, 3, and then next we would go ahead and go on to this interval, right? Okay. So our question would be this, right? Does this interval, right? Does it did it start right before the previous interval started? Ended, right? So that's the question that we need to ask, right? Because we know that the previous interval started before the interval to its right, right? So that's why the only question that's left for us to ask, right, is to ask, did this this current interval that we're on, right, did it start before the previous interval finished, right? If that's the case, then we know that's an overlap, right? Because it started before the previous interval that started before it finished. So that's kind of how we can confidently say, oh, there's an overlap, right? And then once we encounter those scenarios, right, like we said we were going to do, we would extend by choosing, right, the maximum in time out of the three out of the previous interval or this current interval that overlaps with it, right? That's kind of the key aspect of this question, right? So which is the maximum out of two? We can just blindly just choose 6, right? Because this previous interval could have went for from 1 all the way up to like 100, right? Or whatever, right? So that's why we need to do that check, right? Which one is the choose the greatest one possible, because we want to expand it as much as possible, right? Right? So that's kind of what we do here. Okay. So then we would just take care of that, guys. We would do the same thing for the next interval, right? So before we do that, we make sure that we extend it, right? So by doing the extension, this needs to get updated to say 6. All right. So we've pretty much merged them into one big one, right? One big interval, right? Which is the interval that we have here. Okay. Just making it clear for you guys. So now that we have that, right? So the next thing for us to do, we check, right? This for this interval, right? Now we're comparing it with the previous interval, right? Which is 1, 6, right? Which is already, data structure that we're going to return as the output, right? So 1, 6, this interval, right? Did it start before this previous interval ended? Yes, it did, right? It started way later, right? So that's why we end up just there's no overlap, right? Because it's this question that right? Because it started later than this after this ended, right? So we're in good shape. So we go ahead and add it as is, right? There's no overlap. Okay. Or in my handwriting. Okay. So we had 8, 10. Let me make sure I do a little bit better. Right. You guys deserve better. Okay. So we have A10, right? So we add it like that. And then the next thing for us to do is to add. So we go ahead and go on to the future iteration, right? Because we're taking care of that case. Okay. So we go on to this one, right? We check. Does this interval, right? We check it. We always check it with the latest interval that we added in our data structure, right? So that's kind of what we're going to need to have a data structure that we can easily have access to the thing that we added the most recently, right? So the latest data that we added, right? The latest interval we add, right? We want to have easy access to it, right? So the data structure of choice, you guys already know. I guess you should have an idea of what I mean, right? So we're gonna end up using a stack pretty much, right? To keep it simple, right? So we check, right? Did this interval start before this ended? Yeah, it did not start. It started way after this ended, right? So there's no overlap at all, right? So we go ahead and add it as is, guys, right? So that's what we can keep asking the question, guys, right? 15 and 18. So that's kind of the whole gist, right? So let's quickly go ahead and start writing the algorithm. Right? I think it'll make a lot more sense once we see the code and everything. Right? So let me know if this makes sense at all, because I'm really trying to improve and make sure that the way I'm explaining is a lot better for you guys, right? So what's next for us, guys? Right? So we're gonna do. We said that we'll have we'll introduce some sort of a stack thing, right? Just to have access to the previous one. New stack. Okay. So now what we're gonna do is to simply just loop through our interval list, right? And you guys should already see that I'm missing one thing, right? So one crucial thing that we need to do is to sort the intervals, right? So intervals, because they're not sorted. Okay. That's kind of what we need to worry about. So because not sorted, right, we're going to go ahead and sort them, right? So we're gonna pass in this lambda function here. It's sorted by their start time, right? So just like that. I sorted by the start time. Okay. So now we can go with our algorithm, right? So we're gonna handle that case, right? So stack is empty. So if it's not empty, right, we're gonna check this case. And right, if it's not empty, and as that peak, right? So we're gonna check this. Does this current interval, right? Intervals of I. Okay, we're gonna check the start time, right? Does it start, right? Was it start before this ended? The previous one ended, right? The one that's in our data structure already, right? If that's the case, then that's an overlap right there, right? So what we're going to do, we're going to simply modify the end time, right, to be the biggest out of this current one that I have, or this interval, right? I've already shown you guys why that we have that thinking, right? Because we want it to be as big as possible, right? Because if you're merging something, right, you want it to be at least the same size or bigger, right? It's kind of the whole point of merging it, right? Okay, so after that, right, if there's no overlap, we go ahead and just add our interval in there, okay? And then should be in good shape. So what we'll do, we'll create an array list. Let's call it res new array list. And then we just go ahead and pass in our stack to the constructor. And then after that, we'll do just return our result. Int array. I believe that's the syntax. Res that size, right? So you're just converting the data that we have into an acceptable format that this expects, right? That's all that we're doing here. So that's the whole gist of this algorithm, guys, right? We go ahead and sort it by their start time so that we can easily do the comparison, right, with our neighbors, right? if there's any potential overlap. If there are overlaps, then we go ahead and do the merging, right? By, updating it to be the maximum, right? Okay. Let's press run code, guys. For a small test cases, press submit, see everything's fine. Okay, looks like we passed all the test cases, guys. If you guys found value, you guys understood the thought process, it made a whole lot of sense to you guys, in the comment section. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.